Good afternoon, folks. It's really good to meet you today. For the next 30 minutes, we will look at what AWS is doing in the data analytics and machine learning space and how it is moving, providing value to the customers in using data and analytics. My name is Meena. I work as a partner solutions architect within AWS. I've been with AWS for 1 year. And my predominant responsibility within AWS is working with machine learning and AI partners, where we bring in AI partners to build on AWS for customers' requirements. So let's start with the presentation now. So let's face it today, right? So building a sustainable business requires reinvention, possibly multiple times over and over. If you look at back in 2000, only 50% of the businesses that were in the Fortune 500 are now in the Fortune 500 list today. After 20 years, it's all been reinvention. So we see the next wave of reinvention being driven predominantly by data. So building a data strategy and a data-driven organization is imperative to stay relevant now and in the future. Let's start with some numbers before we get into the details. The first one is from the Forrester research. So by just making 10% of data more accessible, Fortune 1000 company will be able to see at least 65 million increase in net income. So this is one of the quote from a famous analyst from Forrester. Another two things are from the IDC report on AWS databases and analytics, where customers are seeing 415% on a 5-year return on investment and 48% reduction in total cost of ownership and operations. So this is just what data is providing you for your organization. But how do we come up to these numbers? By focusing on 3 core business outcomes. Number 1, improving operational efficiency. Number 2, making more informed decisions and accelerating innovation. So what does a data-driven organization look like? We see that there are 3 major facets to the data-driven organization. Number 1, data is an organizational asset, meaning that data is not in silos. Data is not owned anybody within the organization, but it is available for everyone to use. Number 2, data is democratized. Quality data is available and shareable across the organization. And with any data, it is only useful when you actually put the data to work. So data should be able to be made to put to work by different set of personas within your organization. It starts from your data analysts to data engineers to business owners to machine learning and data science engineers. Right. So these are the 3 major facets of any data-driven organization. So how is AWS helping you in driving your modern data strategy? We have defined 3 different pillars. The first pillar is modernize. Modernize meaning moving away from your existing legacy databases into purpose-built databases. I will get into more details on what are the modernized capabilities that are available within AWS and what are some of those purpose-built databases that are within AWS that you can use for different types of data that you deal with. In the previous lecture, we heard about the unstructured data, but unstructured data is just not there, but there are other different data types that are available, like the graph data, the key value pairs and whatnot, and what kind of AWS services are available for you to modernize your infrastructure and the data storage mechanisms into a purpose-built databases. The second pillar is unify. As you modernize your data infrastructure and everything, you need to start bringing the data into a unified location. This is where the birth of data lakes, the data lake house and whatnot comes into the picture. We'll talk about some of the nuances of building a data lake in this lecture. The third, again, the most important one is it's great to modernize your infrastructure. It's great to unify your data, but unless you put the data to work, which is where the innovate comes into the picture, the data is rendered useless, right? So how do you make sure that the data that you have spent on modernizing your data repos, unifying the data, is now put to work through innovative data analytics machine learning services within AWS. Okay, so let's focus on the first pillar, which is modernize. So as I mentioned earlier, modernize focuses on moving away from your legacy infrastructure and data. So why is this important? There are a few reasons why they're important. Right? One, you have to break free of your legacy databases. Say if you want to unify your data into some sort of a data repo, like a data lake or a lake house, you need to have an ability to start building integrations from your data systems of record into your data lakes. By using your legacy systems, you're going to spend too much time on building integrations, custom code to just get the data out of your data repos. So that is one of the key reasons for moving away from legacy databases. Number two, managing these legacy databases are usually high on operational cost. So most of our customers, as we see, are starting to move towards fully managed databases and analytics services, right? So they don't want to look at managing infrastructure and whatnot. So it is basically moving into the cloud and focusing on how can cloud provide or AWS provide a managed service for your databases. Modernizing your data warehouse, yeah, gone are the days where we are buying huge data warehouses and MPP appliances to run your data warehouses and everything. Now with Redshift and a whole lot of variations on Redshift, like the Redshift Spectrum and Aqua and everything, you can basically modernize your data warehouse to handle various types of workloads. Finally, as I touched upon, leveraging purpose-built databases is extremely key, right? You don't want to dump all the data into a relational database or any kind of SQL Server or RDS kind of a repo. Depending upon the type of the database, you need to pick and choose the right data repo for you to use and build applications on top of it. And we will also look at some of these things as we go further. Right. So what does AWS offer in modernizing your entire data infrastructure? Starting from left to right, from a relational database perspective, AWS offers two different flavors. One is Amazon Aurora, which is AWS's built-in relational data repository. We have multiple variations of Aurora today. We have global Aurora databases, we have serverless Aurora database and whatnot. So you have an opportunity to pick and choose the right variation of Aurora database for your requirement. In addition, AWS also support the traditional databases like SQL Server, Postgres, MariaDB and whatnot through a service called as Amazon RDS. Right. So if you have your own SQL Server and everything and you want to bring it into AWS, you can use Amazon RDS and SQL Server's flavor of Amazon RDS to host your SQL Server on AWS. As we move further towards the right, here is where a plethora of NoSQL databases comes into picture. Again, all of these things are managed services that are provided by AWS. So most of the things you really don't have to provision any infrastructure and manage the infrastructure for these databases. Amazon Dynamo and DocumentDB predominantly focuses on key value pairs, JSON related documentation. The next one is Elasticache. Elasticache has a couple of flavors again. One is Redis for Elasticache. And the other one is Amazon's own Elasticache. So you have again options here to depend upon what kind of flavor that you want to take in Elasticache. It's an in-memory database to speed up your in-memory processing and whatnot. And again, Neptune is for any kind of relational data that you are dealing with, graph database, right? So that's where Neptune comes into the picture. So you kind of get the idea here, right? So depending upon the type of the data that you're dealing with, you have to pick a specific service within AWS to optimize the way you store the data, the way you access, and way you build modern applications on top of it. Again, from the perspective of providing these databases, you have a couple of options at a very high level. So number one, AWS's own provided database, like the Aurora database, the Elasticache, Neptune, and whatnot, or using managed databases like RDS, where you can bring in SQL Server or Oracle or MySQL kind of a aspect into it. Right. So this is where our modernized capability lies in. So we we strongly are recommending customers to move to modernized databases based on their data workloads. Okay, let's jump into Unify. So Unify specifically talk about, yeah, you got all your modernized data repositories and everything. You've started building your systems of record and everything. But to start to get value out of the data, you need to start unifying this data and eliminate all the boundaries of the data within those data repositories. This is where unification comes into the picture. Think of it as a boundaryless data area, right? So this is where data lake comes into picture. Okay. So at a very high level, let's look at, pretty simply, how do you build a data lake? So you start with setting up the storage. So here you think about all the different types of storage mechanisms that you want, right? Where do you store your raw data? What do you do to once you cleanse your data, and once you've cleansed it and curated it, how do you enable the curated data for consumption, right? So that's your storage mechanism. As you build your storage mechanism, the other thing that you need to think about is who is going to have access to this data. This is where the security and governance of the data lake comes into the picture, right? How do I build enough security, access control on top of it, so that the data is not accessed randomly by anybody. Once you stood the foundation of the storage and the security and governance, you start looking at ingesting data from different data repositories. Again, there are different data types that we need to deal with. This starts with structured data to unstructured data to streaming from IoT and whatnot. There's a whole bunch of different kinds of data that's going to come in. So you are looking at some sort of an ingestion hub through which you can basically get all this data into your data lake. So now once the data is within the data lake, then you need to start processing the data to move the data across the different storage zones from raw to cleansed to curated and whatnot. And you start building your ETL jobs, right? So this is what we call as data operations or data ops pipelines, right? So these pipelines are extremely complicated to build. It needs to be triggered whenever the data comes in, and it needs to take care of schema changes and whatnot. So there's a whole lot of complications in terms of how you build a data pipeline and how you manage your data ops pipeline. Right? So that needs to be done. Once you're building all of these things, all this work that you're doing in terms of standing up, processing the data, is about enabling this data to be consumed outside your data platform, which is where you need to catalog and search your data, right? And eventually consume the data. So what does AWS provide in building a data lake? At the heart of the data lake, we do have S3. S3 is the central storage mechanism. It's scalable, secure, cost-effective, infinitely scalable. So it doesn't really matter how much amount of data you need to push into the S3, it can hold it. And it can hold any types of data to be stored within S3. But as you start building the S3, the management and security layer comes into the picture through multiple services like, for encryption using KMS, key management service, using identity and authentication using AWS IAM, and also who is accessing what and what is happening within the data lake using CloudTrail and CloudWatch events. So that's your management layer. For you to push data into the data platform, you have a bunch of ingestion services. Again, each of these ingestion services are dependent upon the type of the data that you're pushing into the data lake. Starts with type and the size of the data, right? Snowball is for heavy data sets that you want to push data into the data lake. And there are a bunch of other services for pushing data from databases to files to streaming data through Kinesis and whatnot. So you got all these services. You need to configure these services and get the data into the central storage, which is the S3 buckets. Finally, as you started to push data into the data lake, then you can start cataloging it using AWS Glue, and also using AWS Glue, you can actually start building your ETL workflows. Right. Once you build all of these things, now the data can be allowed to be consumed across multiple repositories, multiple different personas of uses. This includes, business analyst to machine learning to data scientist and whatnot, to Athena, EMR, and Glue and whatnot. Right? This is actually quite an amount of work and tedious work. There is so many number of services out there. You need to bring everything together, stand up everything. So we've been working with customers, and customers have given us some feedback. So we came up with a data lake formation. So how do we bring all of these things under a single umbrella for us to build data lakes seamlessly and effectively? Because this gave birth to data lake formation, and we've been hearing customers' requirements on top of this. So lake formation is, think of it as an umbrella service, which brings all the required facets of a data lake into a single pane of glass, right? So the first thing is storage, which we talked about. Then all the stuff around, glues and the blueprints, cataloging, access control, everything is managed through lake formation. And all the services that are consuming data from the lake goes through the lake formation, which enables seamless access to these data, seamless access to these consumption services. So I talked quite a bit. What I want to do quickly is show you in the screen how it looks like. Let me see if we can see my screen. Hopefully my screen is visible. So what I've done basically is I'm actually logging into my AWS console. As I log into my AWS console, I'm going to click on services. I'm going to click on analytics. Inside analytics, you see all the services that we talked about: Athena, data pipeline, EMR, Glue, and whatnot. Also, we do have lake formation. So think of it as an umbrella service, as I mentioned. So when I click on lake formation, this is what lake formation provides you with. It helps you to organize and ingest data into the data platform, secure the data platform, and enable access in terms of different consuming applications coming through data lake formation. Right? I'm not going to run through because of time constraints, but let me show you how it is done. Right? As you can see on the left-hand side, let me start with register and ingest. I can basically provide where my data lake repos are, the S3 buckets are, which is where I need to store my data, right? Where my S3 bucket locations are. Once I have set up my S3 buckets, which is where I'm going to store my data, which could be raw to curated and whatnot, then I can start building blueprints. Blueprints are nothing but an ability for you to ingest data into the data lake. So there are a bunch of blueprints that are already available within lake formation, but the ones that are not supported under blueprints, you can create your own custom ETL jobs, which I will show you in a minute. Using blueprints, I have a bunch of options, like I can pull it from a data snapshot, I can do incremental, I can do a bunch of other things. All it requires is where is it coming from, where is it getting into, and what is the frequency if I have to run this job in specific set of frequency, and some other few options that are available for you to do so. Right? So it's pretty easy for you to set it up. If the requirement for you to pull a data to the data lake is not available under blueprints, then you can go ahead and create your jobs. These are ETL jobs that you can basically build to push data from your source into the data lake. Right? So a bunch of jobs that you can write, and there are easier ways to build these using Glue Studio. So I'm not going into Glue Studio, but think of it as a drag and drop scenario through which you can basically configure a source and start dragging data into the data platform without too much amount of. Think of it as a low-code environment for you to build your ETL jobs. Right. So once you pushed my data into the data platform, one of the key things is I need to catalog all the data within the data platform. So this is where crawlers comes into the picture. So there are a lot of inbuilt crawlers that I can create that AWS provides, or I can also go ahead and create my own custom crawler. Think of crawler as it looks at your entire S3 repo and starts creating metadata out of the files that are being pushed into your S3 repository. When the crawler gets completed, it basically creates a tabular database lookalike for your data within S3. It's like a metadata repository for you, right? Furthermore, into the lake formation, then you can start building permissions for your lake. So here is where what kind of grants do I need to give to my data. So this is basically a bunch of data. How do I control access to my data? Who can access my data? This is where all the Redshifts of the world, the Athenas of the world come in, make sure that they have enough access credentials to access the data within the data lake. And even within lake formation, I can also provide external data as well. So if you have multiple accounts within AWS, and each account, and you have one account hosting your data lake, and there are multiple other accounts wanting to access data from the data lake, then I can start building a specific set of cross-account hierarchy as well in here. So there are a bunch of other capabilities within lake formation, but I think you get the idea, right? So rather than you trying to assimilate a whole number of services across, now lake formation provides you under a single pane of glass. Let me go back to my presentation. Okay, so it's still, I built everything, but the data ops is still a bigger concern for me, right? Because data ops, I have to build my ingestion pipeline, I have to build my transformation pipeline, I have to build my curation pipeline and whatnot. And this is quite an amount of work, right? So again, we listen to the customers, and what we came up with is a serverless data lake framework. So serverless data lake framework, think of it as cloud formation templates or deployment accelerators for you to build your data lake. As the name suggests, serverless meaning there is no service that you need to provision for you to build your data lake. I mean, you do not have to spin up any servers, any EC2 instances, nothing of that sort. Everything is serverless. You only pay for what you use, and we auto scale based upon the type of data operations that you do, right? I mean, if it's a huge ingest job, we scale it based on your requirement, right? And there are step functions that help you orchestrate the end-to-end data operations within this. So how do you start up with your serverless data lake? There is quite a bit of architecture and getting started guide that we have provided on this particular link, which is serverless data lake framework, right? There are also workshops that are available in this, which can help you get started with serverless data lake, building a serverless data lake with ease, right? So again, as you see, slowly with building all your services to providing an umbrella using lake formation, and taking it further one notch up and providing a framework and a deployment accelerator, which is the serverless data lake framework for you to build your data platform now. Moving ahead, right? As you start building your data platforms, as your company grows and everything, you are looking at multiple different teams wanting to stand up their own set of analytics capabilities within your organizations. Think of all your different verticals, your finance domain, a HR domain, a whole lot of these domain related capabilities comes into the picture. So here is where the whole data mesh concept came into the picture. So how do we build, rather than trying to assimilate all the data into a single data lake, but how do we build a distributed data mesh through which we can provide relevant services for specific set of users within each of the domains that they work. So this was based on the paper that was written by Martin Fowler in 2018, a data mesh architecture. Right, so data mesh architecture came into the picture, and we responded to customers' requirements. And by integrating the lake formation and the lake house architecture, which is what I'm showing in here, we created what we call as a data mesh architecture in here. Right. So the key concept of the lake house is, in the center of the lake house is your S3 and the data lake in here. But the lake house, depending upon the type of persona that your company has, you can start provisioning or using the services for those personas. So for example, if your company has a bunch of descriptive analytics folks who are willing to build dashboards and data warehouse related capabilities, then the the data lake can connect to Redshift, and you can start building your warehouse related capabilities. But if you have a bunch of folks who are more focused on data science related capabilities, then you have SageMaker integrated with your data lake, where you can pull data from the data lake into SageMaker to build your machine learning pipelines and MLOps pipelines and whatnot. Similarly, rest of the personas that are covered in here, right? So by integrating a data lake formation and a data lake house architecture, we are now starting to support data mesh architecture. And I've given a blog post here where this goes step by step on how to build a data mesh architecture within AWS. And also given, so one of the biggest problem areas with distributed data is access control across multiple of these different accounts and different data lakes at different places. And there are reference architectures that AWS has provided for you to build a data mesh architecture where through reflection of data from one lake formation to another, you can basically have a central governance model, right? Though there are multiple data lakes in here, there is a central governance set up within a central account, and each of the lake formations can connect to each one of those things to build a centralized data catalog, right? So how do you scale a single data lake into a distributed data mesh is something that can be done pretty seamlessly within AWS. I'm going to rush quickly to the last pillar. The last pillar, so we talked about modernizing data and what are the services within AWS to modernize. We looked at unifying the data and kind of a maturity model on the unification with data lakes, and and building all the components of the data lake to a lake formation, and one step ahead with serverless data architecture, and taking ahead into a distributed data mesh and whatnot, right? So you've unified all the data. Now it's time for you to innovate on top of the data platform. Right. So this is the ML stack that AWS has. There are 3 different layers of this ML stack, right? Why is this created in such a way? Because we want to address the different personas within the ML space. This includes people who are really good in machine learning to people who are starting to build machine learning to absolutely no code machine learning users, right? On the top of the layer, what we have is AI services. Think of these AI services as pre-built models, trained models that are available for you to use. Just a call using an API. Some of the AI services here focuses on vision, text, and whatnot. So I'll give you an example. Comprehend here. Comprehend focuses on unstructured data. So give it an unstructured data, and you analyze the data. Comprehend and provide you with what are all the key entities within your unstructured data. What is the sentiment within unstructured data? Is there any PA related information that is available within that unstructured data and whatnot? This is just one example. The number of services on the AI services side is continuously increasing, and we are starting to focus on more industry specific stuff like healthcare and industrial automation and whatnot. On the second layer of the ML stack is Amazon SageMaker. This is for data scientists who are willing to build models, custom models from scratch, right? So the entire landscape of labeling the data to preparing the data to creating features to building feature engineering and taking the data, training the data, and deploying the data, and post-deployment managing and monitoring the data, monitoring the model in production can all be done under a single roof, which is Amazon SageMaker. Right. I'll quickly show you how Amazon SageMaker looks in a minute. But before that, the last layer is the ML frameworks and infrastructure layer. These are for this hardcore data scientists who wants to bring their own frameworks to start building their models. So depending upon where your expertise level on the ML lies, you can use any of these layers to start building and start leveraging AI ML within AWS.
Hey, Mena?
Yeah.
Mena, we've got a few minutes left, so if you could quickly summarize, I'd appreciate it.
Absolutely. Yeah, I will do so. Just give me 1 second. Which means that I'm not going to do a demo. So SageMaker. As I started talking about SageMaker, SageMaker is again an umbrella service, and it has a bunch of services underneath for preparing, building, training, and tuning. All of these things available in a single pane of glass using SageMaker Studio. So last but not the least, building the model and everything is all cool, but for machine learning to be widely used, it needs to be brought closer to the data. So this is what AWS is building, creating today. So as you start building your models and everything, you're starting to make sure that the models are accessible and embedded into your purpose-built databases. Like, I mean, we have Amazon Aurora ML, we can Neptune ML, Redshift ML, Athena ML, and whatnot, right? So as you start for using all of these machine learning capabilities in your purpose-built databases, you really don't need to have machine learning capabilities, but those pre-built models can be called using, for example, in Aurora, using a SQL statement, and starting to build predictions within your databases. Okay, so essentially, in summary, right? So we looked at modernizing your data repos. How do you unify building the data lake and putting your data to work through innovation using AI ML services and more. That's pretty much what I had for today. Thank you, Ron.